Hello Godotneers! When you are creating a game in Godot, it is often hard to decide how to structure all your nodes and scenes. Which nodes should go into which scene? Which nodes should talk to each other and when? They all somehow need to work together, but it seems very easy to turn everything into a big bowl of spaghetti where every node just seems to talk to every other node. So we are going to explore how we can structure a game into components and how these components can work together without creating a tangled mess. This is a beginner to intermediate level tutorial. You should know the very basics of Godot, for example how nodes and scenes work, and you will also need to know some GD script as we are going to look at quite a bit of code. There are a lot of concepts covered in this video, and therefore it's going to be quite long. If you need a break, feel free to pause the video and come back later with a fresh mind. So for this tutorial, we are going to build a little tower defense game and we let it play underwater. How does a tower defense game usually work? Well, you have some units that come from one side of the screen, in our case from the right, and you have some towers that you can place, and these towers try to prevent the units from getting to some other position, well, in our case, the left side of the screen. And just from this little description, we can already identify a few components for our game. So we are going to have some attacking unit. In our case, we're going to use a fish for that. And we are going to have some towers. And maybe we are also going to have a component that represents a projectile that the tower shoots at the fish. So let's start with the fish. This fish is quite big and it looks into the wrong direction. So we first fix that. And now we want the fish to move. So we add a script and we call it fishgd. And inside of the script, we write a physics process function. And then we just change the global position by some vector 2. So we want to move horizontally with 200 pixels per second. So every time something is per second, you multiply it with delta. That's an easy rule of thumb. And we don't want to move it vertically. And sure enough, our fish moves to the left. That is great. That was easy enough. So let's try to build a tower. So this is going to be our tower. And I'm going to name it tower. The tower just sits here, it doesn't move, so we don't need a script for it. That is also great. But the tower does something very important. It needs to shoot something at the fish. So we need some kind of projectile, and I have also prepared something like that. It's a little bit too big. And we also rotate a bit. So now we have a projectile. So how could the tower now shoot the projectile? Well, we could try something like this. We could make the projectile a child of the tower, and maybe we move it around here, and we add a script to it, tower GD. And now the tower will move the projectile for us. That sounds like a good plan to me. So we write another physics process function, and we need to access this projectile somehow so we can move it. And a really simple way to do this is just using a node path. So we can make a unique name out of this. We drag this over here with control. And now we have access to our projectile. And then we can do pretty much the same thing that we did with the fish. We just change its global position and move it by some vector 2. Let's say 400 per second. Again, delta is per second. And let's try it out. So great, our tower can now fire projectiles. Oh, well, it didn't hit the fish. That was not good. Okay, so how could the projectile somehow find out that it's near a fish and then destroy the fish? We could try to use the global position of the projectile and maybe compare it to that of the fish. So, well, let's quickly do that. Let's drag in the fish. Then we can maybe do something like if the projectile's global position is not too far away to the fish's global position, and let's say they're, I don't know, 20 pixels apart, well, then we can just destroy both, right? So we can say fish Q3, and we can also say projectile Q3. So let's see how that works. Something worked. But we get an error. So it complains about that this projectile was freed and now we cannot use it anymore. So maybe we just say if the projectile is no longer valid, we don't do anything. Let's try if that helps. Hey, fantastic! Our projectile shot the fish. We have a tower defense game now. We can go home now. Well, not really, because this is a real mess. This is not the way in which we should build a game. We have so many problems here. The first really obvious problem is that we don't have any more fish and we also don't have any more projectiles, so this is gonna be a really short game. But we already have produced this kind of spaghetti that I was talking about in the beginning of this video. Now the tower knows about the fish, the tower knows about the projectile, and the tower does most of the work. So we need to think about what should a component be? Is a component just a sprite that some script moves around, or is a component something else? Ideally, a component is something that works independently of all the other components around it, and it knows as little as possible about these. Because then we don't have this spaghetti, right? If the tower doesn't need to know where the fish is, well, we don't need to have these variables. Also, a component should allow us to configure it in a way that stuff that is relevant to the gameplay is easily accessible. And right now, if we want to change the speed of the projectile, we need to go into code. If we want to change the speed of the fish, we also need to go into the code. So let's restructure this and build it in a better way that doesn't turn the whole game into a mess of spaghetti. So let's first start with the fish, and we are going to replace this here with an export variable so we can easily change the speed of the fish in the inspector. So we make it a variable called speed and we put the 200 in here, and then we can just use minus speed here. So now if we look in the inspector, we can see, okay, we can now configure the speed of the fish without having to go into the code. And this is really helpful when we do prototyping and want to see how our components work together. We can quickly change a few values and see how the game plays out with these new values. Okay, so the more pressing problem is the projectile. Right now it's just a sprite, and maybe it is better if this projectile does its own movement. So we move it out here. And we can also remove this unique name. We add a script and we call this projectile. And inside of this, we can pretty much do the same thing as we did with the fish. So I'm going to quickly copy this. And we maybe start with a default speed of 400, but the projectile needs to move to the right. So we don't use negative speed, but we use positive speed. Now we have a projectile that can move on its own. And this allows us to remove all of this stuff from the tower. So the tower right now does not need to do anything because the projectile moves on its own. That is a lot better. And you see how we already simplified this quite a lot. Now it would be good if the tower could somehow create new projectiles. So how would we do that? Well, we can save this projectile as a scene. We can right click on it and select Save Branches Scene. Then we save it into a new scene. And what a scene is in Godot, it is a description of how nodes are built up. So it's not the real node, it's just a description of it. And now we can, in our tower, create an instance of this scene. So we make a physics process again. And now we need to create an instance of the scene. How can we do this? Well, we can drag it in here and we get a preload from Godot, which will load this scene. So now we have the scene loaded and we need to assign it to some variable. So we call this maybe projectile scene. And now we create a new projectile from this description of a projectile. So we say projectile scene instantiate. We also need to put this into a variable. So we call this maybe new projectile. And now we have a new projectile. Isn't that great? So let's try it out if this works. And maybe to see if it really works, we delete this one. And let it run. It doesn't work. Why didn't it work? The reason is that we just created a new node for this projectile, but we didn't add it to this tree. So right now we just have a new node that is floating around somewhere, but it's not added to the tree. And if you don't add it to the tree, then Godot will not render it. So we need to add it to the tree. And where shall we add it? For starters, we could just add it to the tower as a child. Let's see how that works. So we say just add child. new projectile, and we run it again. That is adding quite a few projectiles, so that is way too fast, and we need a better way of doing this. So how can we do this? What we want to do is we want to spawn this projectile in a regular interval. And there's actually a built-in component in Godot, which is called a timer, and we can use that. So we add a new child node to this, and we say we want a timer. And in this timer component, we can set a wait time, and the timer will then tick with this wait time. Okay, so now the timer is ticking, but how do we get to know about this in our tower component? After all, the timer is a built-in node of Godot, and it doesn't really know anything about towers. So how can we tell the timer, well, could you tell our tower whenever it is time to spawn a new projectile? And the way to do this in Godot is called signals. If we have a look at this node tab here, you can see there's an entry called signals. And you can think of signals as some kind of mailing list that a node offers where you can subscribe to. So the timer has this timeout mailing list, and now other nodes can go to the timer and say, hey, I want to subscribe to your timeout mailing list. I want to be notified whenever you have a timeout. That would be cool. So how would we do that? How would our tower now talk to the timer and say, I want to be notified. I want to be on that mailing list. Well, the tower needs to talk to the timer. So an easy way to talk to the timer would be to use a node path. So we just drag this in here. And we also maybe make this a scene unique node because there's really no reason to not use scene unique nodes these days. And now our tower in its ready function can ask the timer, hey, can I subscribe to your timeout mailing list? So we say timer, timeout. This is the signal we want to subscribe to. And to subscribe to a signal, you call connect. And when you subscribe to a mailing list, well, usually you give your email address so it knows where to send the notification to. And we do a similar thing here, but our tower obviously doesn't have an email address. It only has some functions. So we give it the name of a function that should be called. So we make a function on timer timeout, and then we give it the name of this function on timer timeout. It's important to only give the name because if you add these parentheses, you will call the function, and we don't want to call the function. We just want to say this function should be called. And now we can move the projectile stuff in here, and we can try it out. Oh, it didn't work. Why didn't it work? We still need to start the timer, so let's do that real quick. Timer start, and try it again. And yeah, we have projectiles. But why are they spawning down there? That's not where they should spawn. That's not good. So let's have a look at our projectile scene again. And we can see that when we created the scene, it moved the projectile somewhere here. There's an easy fix for that. We can just reset its position to the center. And if we go back to the tower and try to play it now it's working a lot better. So now it would be nice if the projectile would be able to actually do some damage to the fish. So let's have a look at our main scene and try to think about this problem. So we add a little projectile here, so we have something to talk about. And now we can think about how we can solve this problem. So the projectile, it moves from the left to the right. And when it's near the fish, it should destroy itself and deal some damage. But how can the projectile find out that it's actually near a fish? We tried to compare the positions of the fish and the projectile when we had all of this code in the tower, but we saw that this doesn't really work out because for this to work, we need to have access to the fish and the projectile in the same script so we can compare their positions. And we cannot really use a node path for this because if I duplicate this fish, then it gets a new name and then it also gets a new node path. So that doesn't work. So how can the projectile now get an idea that it is around a fish? What we can do is we can use Godot's physics system to help us with that. There's a node in Godot which is called an area, and this can detect other physics objects that are around it. So let's add this to the projectile. We add a child node called an area, and this area needs to have a collision shape. And we're going to choose a circle collision shape. And the collision shape basically tells the physics engine what is the region that we want to look for other physics bodies. Now we have this area, but this area can only detect physics bodies. It cannot detect sprites. So we need to make our fish a physics body. So we add a character body 2D. This is some built-in physics body of Godot that has collision, but also allows us to move it around. And then we can drag the fish sprite into the character body 2D. We also see a little warning here, which tells us that this character body also needs a collision shape. So the physics engine knows how big the fish actually is. For this, we could maybe go with a capsule shape. And it's now moved up here and the fish is up there. So we move everything to the center. And now we can set up the collision shape and rotate it a bit. And that should about do it. So now we have a collision shape on our fish and the area can detect it. So we can move the fish again to its correct position. Now we can go back into the projectile and do something with the area that we just added. And this works very similar to the way that the timer works. So the area also has some signal or mailing list, if you will. And there's a lot of stuff that you can subscribe to. We are interested in this body entered signal, which tells us when somebody enters into this area. So now we could again create a variable for the area and then connect the signals, but there's actually a quicker way to do that. We can just right click on the signal and click on connect. And then we say we want to connect this to the projectile script and we want to create a method on area2d body entered. And now Godot has done the connection for us. And we can see this by this little icon here on the area2d. And we can also see this by this icon near the function that this is connected to something. So if we click on this, we can see that this function is connected to the body entered signal of the area. So this is a quick, nice way to make signal connections without having to write a lot of code. For starters, we just print that we hit something. So we can try it out. And well, we hit something, but it doesn't really seem to work. Why is that? Whenever we want to debug stuff like that, Godot has a very helpful feature. We can go to debug and say visible collision shapes. And that will show us the collision shapes when the game is running. So yeah, now we can see why it's working a bit strangely, because our fish is swimming and the collision shape stays here. And the reason for that is that we have the fish script still at this sprite, and the sprite is its own component, right? It moves independently of the character body. So this is not what we want. What we want is to have this script at the character body. So we detach it from the fish and we reattach it to this character body. And now we need to do a bit of changes because the base node is now no longer a sprite but a character body. So we change this. Also, character bodies don't move by changing their positions, but they actually have a method for moving them. So the physics engine knows that we moved the node. With the character body, it works like this. We have a velocity that we set, and then we call move and slide. And you see that we didn't add delta here because the character body does the delta calculation for us, so we don't need to do it. So let's try again if that works. And now we can see that everything moves together and we get these hit something messages whenever a projectile hits a fish. So that is fantastic because now our projectile has found a way to find fish without actually knowing about fish, right? There's nothing about a fish inside of the script. This projectile is completely independent of the fish. It can find anything that is a physics body. How do we now do damage to the fish? Because we just said that the projectile doesn't even know that this is a fish. So how can it communicate with it? To do this, we can make a little contract between our nodes. We can say that whenever something can be damaged, it has a function called take damage. So we give the fish a take damage function. And then our projectile can look at the thing it just collided with and ask, do you have a take damage function by any chance? And if the fish has a take damage function, the projectile can just call it. And if it does not have a take damage function, then the projectile will simply ignore it and move on. So let's go back to the projectile script and try to implement this. So first we need to know with what we collided. And thankfully, the mailing list of the area, the signal, it not only includes some information that we hit something, but it also includes the information what we have hit. And this is this body that we are getting as a parameter for this function. We can ask the body as method take damage. This way we can know, okay, this body has a take damage function, so we can call it. And we can do body take damage. And since the damage is also something that affects the gameplay, it's probably a good idea to make this configurable. So we write an export for the damage, maybe 25, and we put it in here. And then we can destroy ourselves. We just can do a Q3. So if we try this again, we can see that really nothing happens, but we also don't get an error because this fish doesn't have a take damage function. So nothing will happen. The projectiles will just move on and on. So next we add a take damage function to the fish, and maybe let's do a bit of renaming here so we don't get confused with what the fish actually is. We can now add a function, take damage, and it takes the damage as a float. And now inside this function, the fish can do whatever it needs to do when it takes damage. For now, we can just say whenever we take damage, we just Q3 ourselves. And let's see if that works. Fantastic. Now our projectile has eliminated the fish. And if we look again at the code of the projectile, we can still see that it's totally independent of the other things around it, because it only checks if there's a take damage method. It doesn't even know that there's a thing called a fish. This projectile would work with everything that just has this take damage method. So now we can kill fish with the projectile, but it's probably not going to be a lot of fun if the fish is always instantly killed. So the fish needs to have some health. And before we can do that, we first create a scene from it. So the fish is now also nicely organized and not a huge set of nodes in our main tree. So we can open up the fish scene and we can add some health bar to it. We see that the fish moved a bit off screen. So we move it back to the center where it belongs. And now we can add a health bar to it. So we add a child node and we maybe use a progress bar for that. Like this. And now we can go to the script. So first we add an export for the health because we want this health to be configurable. So we can easily tweak our game variables. And we also need to initialize the progress bar. We can do this in ready. And we need a variable for our progress bar. So again, we do a right click, access as unique name. And then we can drag this in with control. And we already get our onReady variable for this. And then we can just say progress bar max value is health. So the maximum value should be always the health that the fish has at the start of the game. And we set the current value to be also the health. So we start with 100%. And inside of take damage, we subtract the damage from the health and we update the progress bar. And if our health drops to 0 or below, then we destroy the fish. And we can try this out. But our fish moved up here because we changed it in the scene. So we move it again to this position. And now we can see that our fish is losing the health more slowly. And that makes for a much more interesting game. So we have just added a new feature to the game that fish can have health. And because we designed our components to know as little as possible about each other, we could add this feature without having to change anything else but the fish itself. So now we want to spawn new fish because just having one fish is rather boring and the game would be very short if we just had one. So how could we do that? A fish can obviously not spawn itself, and the tower and the projectile should probably also not spawn new fish. So we are going to need a new component for that. So let's add a new component, and as a base node, we could maybe use a marker2D. Marker 2D is basically a node 2D, but it has this little nice feature that when you have it not selected, you can still see its position. And maybe we call it spawner. And we add a script to it. And we call it spawner as well. And we delete all of this. So we can now add a function where we can spawn something. And now we want to spawn a fish. And we already did a similar thing in the tower. So let's quickly have a look at how we did it in the tower. There we loaded a scene using preload. Then we made a new instance of it. And then we added it to ourselves. So let's maybe do it the same way and see how that works out for us. So we drag in the fish. We assign this to a variable, fish scene. And then we create a new instance. Also assign this to a new variable. And we add this as a child of our own. Let's try it out. Well, it didn't work because nothing is calling this function. And this brings us actually to the next question. How often should we spawn something? We could use a regular timer like we did in the tower, but then the fish would come in a regular row, which would look somewhat unnatural. So we want to have random spawn intervals. So let's first add two variables where we can configure the spawn intervals. So we have a spawn interval min, which is maybe 2 seconds, and we have a spawn interval max, which is maybe 3 seconds. And then in the ready function, we call spawn something. And once we have spawned something, we need to wait for a little time. And we can use a scene tree timer for that. Get tree, create timer, and we want to wait a random time between the min and max interval. So we can do a randf range, spawn interval min, spawn interval max. Now we get a random time interval between 2 and 3 seconds. This drives the timer. And create timer returns a timer object. If we have a look at here, it returns a scene tree timer object. And the scene tree timer, it also has a timeout signal, very much like the normal timer that we have. So we can now connect to this signal and be notified when this timer times out. So we say timeout, connect. And whenever this timer times out, we want to spawn a new thing. So we just say when this times out, please spawn something again. We don't need to worry about this timer being garbage. It will automatically be discarded when it times out. So Godot will take care of that. So let's try this. And now we get a nice, somewhat random row of fish. And that is great. But what if we wanted to spawn more than one type of fish? So maybe we have a second type of fish that is bigger and has more health. Let's maybe quickly do this. We can go to our fish scene and we can duplicate it. And we call it maybe big fish. And we can make the sprite a bit bigger and the collision shape a bit bigger. And in our configuration, we give it maybe 200 health. And maybe the big fish, they move a bit slower. So maybe go with 100. We now see the benefits of having this fish in its own little separate configurable component, because we can just use the same script to make a different kind of fish and give it a different configuration. Okay, so now we want to spawn more than one fish. And let's go back to our spawner. Now the problem we have is that this spawner actually knows about what it should spawn. So we have hard-coded a reference to the fish here. Of course, we can add a second line and hard-code a reference to another fish, but then every time we want to add a new kind of fish that should be spawned, we always need to change the code. And this is not really a nice way for a component to behave. So how can we make this a bit nicer? Well, we can add another export and we name it maybe items. And this is an array of packed scene. And you may now wonder, what is this packed scene thing? Well, this is the object that represents such a TSCN scene. It's the object on which we call instantiate. Now we have an export that allows us to give it scenes, and now we can use this and say, okay, we pick a random one of these items, pick random, then it instantiates it, adds it, then it does the timer thing, and the timer will then call the spawn something again after some time has elapsed. So all we need to do now is go to our spawner scene, and we now have here a new property where we can add the scenes that we want to spawn. So we add 2 of them, and then we can pull in the big fish and the normal fish. And let's see how that works out. So it spawns a small fish and a big fish and another small fish. So that works quite nicely. However, we can see that the fish collide with themselves and that the big fish now prevent the small fish from going further. So we need to fix that. But this is a rather easy fix. So we can go to the fish and to the character body, and then we go to collision over here, and we just remove this mask here. What this will do, it will prevent the fish from colliding with any stuff that is also in layer 1. So the fish is in layer 1, we need that to be in layer 1 so the projectile can detect it, but if we remove this mask, then it will not collide with themselves. And we can do the same thing for the big fish. And now we can try it out. And now we can see that the small fish can swim past the big fish without being blocked. And this is what we want. Now it would be nice if the fish were able to actually damage our tower. So first the tower will need to have some health and some health indicator. Let's quickly put the tower into its own scene. So it's going to be in tower, TSCN, and we are going to reset its position. Okay, now we can add a progress bar to indicate the health. It works pretty much the same way as it does in the fish. So we are going to create a health variable. We are going to have an on ready for our health bar. We are going to initialize it. And now we can have a look at how the fish could damage the tower. So we go back to our fish scene. And the first thing is that the fish would need to be able to detect when it has collided with the tower. And we could use an area for this, similar to how the projectile was done. But I want to show you a different way of doing this. And this is by using slide collisions. So any character body can detect that it collided with something else during this move and slide method. And for this to work, of course, the tower will also need to be some physics body, because right now it's only a sprite. So we will have to do a little bit of reorganization. We create a new node and we use a static body 2D because we don't want the fish to be able to move the tower by colliding into it. Then we make this the root of our scene. So right click, make scene root. Then we move all of this as a child of the static body. And we move the script to the top and rename it. And then we need to add a collision shape so the physics engine knows how big the tower is going to be. So we go to 2D view, add a collision shape. A circle makes sense for this shape that we have, like this. And now we only need to do a minor change here. We say this now extends static body 2D. So now our tower is a physics body and our fish can collide with it. The move and slide function will take care of that, but we want to know whether we just collided with the tower. And we can ask the character body 2D, with how many objects did you collide during the last move and slide? So we say collision count equals get slide collision count. Now this variable holds with how many objects we just collided during this last move and slide. And now we can walk over them. For I in collision count. Now we need to get information about what was the actual object that we collided with. Because right now we only have a number. We only know with how many objects we collided, but we still don't know with which objects we collided. And we can get that by asking the character body, can you give me more information about this collision, please? So we say collision info, get slide collision. And then we can give it the number of the collision for which we want more information. So now we get back a collision info object, and from this we can get the actual object with which we collided. So we can say var collider is collision info get collided. And now this variable contains the object with which we just collided. So it's just a different way of getting the object with which you just collided, but this time we pull the information from the character body rather than the way that we did it with the area, where the area would notify us about a collision. So both things are possible. Which one to use depends on your needs. If you need to do a move and slide anyway, the physics engine has already made all these calculations for collision, so you have already spent the CPU for this. So it might be a good idea to just use what the physics body can give you. But if this seems to be too troublesome, you can of course also use an area. But I wanted to show you how this could be done. Now we want this fish to damage the tower. And we can use the same contract that we have designed for our projectile, where we said that every object that can take damage just has a take damage function. So we go back to our main scene and our tower has moved. So let's quickly move this over here. And maybe we add another fish so we can see what we're talking about. The fish would collide with the tower, and then the fish would ask the tower, do you have by any chance a take damage method? And the tower would say, yes, I have a take damage method. And then the fish can say, okay, fine, you just now take this much damage. Thank you very much. And then the tower does whatever it needs to do when it takes damage, and the fish will just destroy itself. So again, we want these components to know as little as possible about each other. So the fish doesn't really care what the tower does when it takes damage. How this is done exactly, it's the business of the tower. So let's go back to the fish and let's implement this. So we can say if the collider has the method take damage, then we can call this method. Collider take damage. And again, the amount of damage that the fish will deal is some gameplay relevant thing. So it's a good idea to have this as an export. Maybe impact damage. And I don't know, maybe 50. And then we can deal the impact damage down here. Now our tower still needs a take damage method, and we can pretty much copy this from our fish, except that we named the thing health bar here, which is not good. I think we should name things consistently, so we're going to rename it health bar here as well. So just that things are consistent. And then let's quickly check in the tower that everything looks okay. Well, we still don't have the health bar looking right, so let's quickly fix that. So now we can try it out. So now interesting stuff happens. The fish didn't seem to damage our tower at all, but our projectiles now seem to damage our tower, which is not good. So the good news is that our contract actually works, because what happens is that the projectile is spawning like this, and the area will immediately report a collision with the tower. And then the projectile will ask the tower, do you by any chance have a take damage method? And now the tower says, yes, I have a take damage method. So the projectile damages the tower and then destroys itself, which is not what we want. So we need to have some way of telling friend from foe. The projectile should only attack the fish and it should not attack the towers. There's a really neat way in which we can do this in Godot, which are groups. And you may have seen groups already when we were looking at the signals, because there's a little groups thing here. Groups are little stickers that you can apply to each Godot node that is in a scene. So you can put a little sticker on it and you can put any name on the sticker. So we could go to the fish and we could say the fish is now in the enemy group. So we put a sticker on it which is saying this is an enemy. And we also see this with the little icon here. We should also do this for the big fish. So we also put this in the enemy group. And we put the tower maybe in the friend group. And now we need to add some code to our projectile so it only attacks enemies. So we can go back to the projectile and we first check if the body is in group enemy. And only if that is the case, we execute this rest of the code. So let's try if this works. maybe delete this projectile here. Yeah, now this seems to work a lot better. So the projectile will no longer damage the tower, but it will still damage the fish. Okay, but we still have the problem that our fish do not damage the tower. It looks like they don't even recognize the collision. So why would that be the case? Whenever we have a collision problem like this, it's always a good idea to look at the collision layers, and we're going to look at the tower. And the tower is in layer 1 and has a moss 1. But our fish is also in layer 1, but has no moss. So it will ignore everything that is in layer 1. So a quick fix would be that we just put our tower in layer 2. And we don't really need the moss, but anyway, we can set it. And then we say to the fish, well, you check whatever is in layer 2 so you can collide with it. So let's check if that works. Yeah, that worked a lot better. However, our fish fully destroyed our tower and just moved on. So we need to add a little bit more code to our fish. And that is when it has given the damage to the tower, it should destroy itself. Q3. And now we can try it out again. And this has worked. So tower has lost 10% of its health and the fish has destroyed itself. Fantastic. Now we want to detect if a fish has left the screen. And we already know a way in which we can do this. We can do this with an area. So we could make ourselves a component that is an area. And we call this maybe fish detector. And we are going to add a collision shape. So we can set a size. And we're using a rectangle shape and make it this big. So every fish that now leaves this area needs to go through this little fish detector. And we want to count and display to the player how many fish have left the game. So to display something, we will need some label at least. So we call this maybe fish through label. And since it's going to be a UI, we want to layer it across everything. So we are going to add a canvas layer and put the label in here. So in case we want to add a camera later, that it doesn't move around. And we give it a 0 for starters. And maybe a bit bigger font so we can actually see something. Now we can see it. So now whenever this fish detector detects something, we want this label to increase. Since we are trying to build components that are self-contained, it would be good if the fish detector doesn't really know anything about this label. And maybe it's also not good if the label knows about the fish detector. This score is not only important for showing it to the player, it is also important so we know when to end the game. We can say we have 10 units that can go through, and if 10 units have come through, then the game is over. So we would have to have a third component that somehow keeps track of the score and then can update the label and can also trigger the game over. And you're going to have such a component in almost every game, which has the main purpose of just organizing how other components work with each other. So in this game, we're also going to make one, and we are going to make this node here, the main node, this component that organizes everything. So we add a script to the main node, and we call this game. And we're going to delete all of this. And now this node will do a little bit of everything. It will get notified by the fish detector, and it will update the fish through label. In order to update the fish through label, it needs to know about it. So we are going to make a unique name out of that, and we're going to drag it in. So now this node knows about the fish through label, and using a node path is totally fine if the node is below you and under the control. So this label is never going to move anywhere else. It's always going to stay here. And now the fish detector should inform us whenever something entered this thing. So what we can do is we can use a signal. So we are going to connect the body entered of the fish detector to the main on fish detector body entered. Now we need a counter. We make an export for maximum units through, and we say maybe 5. And whenever something has entered the fish detector, we don't really care what it is because it can realistically only be a fish. So we just say we reduce the maximum units through by 1, and then we update the label. So to speed this a bit up, we are going to use this fish and put it here so it can go right through and we see that everything works. Okay, that was almost correct, but you saw at the start that this is 0. So we forgot to initialize our label. And now we should get a 5 and 4. And maybe it is also a good idea to move the area a bit to the left, so the fish needs to fully leave the screen before we count it. So let's see. If we move the fish here, then we can move the fish detector here, and it should work out nicely. So let's move the fish back and try it out. Yeah, that is better. Okay, we have a fish detector, but what happens to the fish that move out here? If we have a lot of fish, well, that's going to be a lot of fish on this side of the screen that nobody sees, but that Godot needs to calculate. So it would probably be better if we kill every fish that has come into the fish detector. So we add a script here, and now it's no longer a fish detector, but it's more like a fish grinder. We also rename it fish grinder. And now we can connect the same signal to our fish grinder. So yes, like you can subscribe to your own mailing list, any component can also listen to its own signals. So that works. So we say onBody entered, and everybody that has entered, we just destroy. Now we need a way of seeing whether this actually works. So we go back to our 2D scene here and rename this fish to be our test fish. And maybe we move it a bit over here so we have a bit more time to set everything up. So let's see. And I'm going to pause this real quick because there's a remote tree that you can access only when the game is running. And when you click on this, you will see what is actually happening inside of your game. We can now see our test fish here. And now we can continue to run the game. And the test fish goes through. And now we see that it has disappeared. So our fish grinder actually works. And it also has countdown to 4. So you see it also works if we connect the same signal to multiple different components. Now we can detect if fish leave the game, and we also have all the information that we need to know whether the game is over. But it would also be nice if we could count whenever a fish was destroyed by a projectile or when it was destroyed by hitting this tower. So we could give the player some score for this, which the player could then use to buy new towers. So let's maybe add a score label for that. So we add a new node, and this is going to be a label, and we call this score label. We make it a scene unique name. And we're going to change the font size. By the way, this is really not the way how to make UI. If you want to know a better way how to make UI, then watch my UI basics video. We're just doing it quick and dirty here. So now we have the score up here, and we can also add this to our main component. But now we have an interesting problem. How does our game component get to know that a fish has been destroyed by a projectile? So let's check which other component could tell our game component that this has just happened. Let's have a look at the projectile. Could the projectile do it? Well, no, it cannot do it because the projectile only tells the fish to tell damage and the fish does the destruction itself. So the projectile is out. Could the tower do it? Well, obviously it cannot because if a projectile kills a fish, then the tower doesn't know about it. Could the fish do it? Well, at least the fish knows when it's going to be destroyed, so that would be a good place to start. But the fish doesn't really know about our main component up here, which is not good. So how can we get out of this? One way to do this would be to create a so-called autoload. And an autoload is basically a component that is globally available in the whole game all the time. So everyone can access this component no matter where they are in the tree. So let's explore if that would be an option. So we could create a new script and we call this point counter. And this component would then have some function where we can count a point. So we could say func count point. And right now we are not doing anything with that. And now we go to project settings, and there's a tab Autoload here. And we can select our point counter here. And we need to give it a name, point counter, and then we add it. So now what we have is a node that is named point counter and that we can access everywhere. So let's maybe add a quick print here, counting points. And let's use this in our fish script. So the fish is destroyed when it either collides with a tower or when it is destroyed by a projectile. So we need to call our point counter here and here. And because the point counter is an autoload, we can just call it by its name. So we can just say point counter, then count point. And we can do the same down here. And then we can try it out. And maybe move our test fish down here so we get a bit quicker feedback. And let's see. And boom, the fish has been destroyed and we got a counting points down here. So now we have 50% of the way. The point counter knows about that a fish has been destroyed, but we still need to get this into the main script. And since we want to inform the main script whenever this happens, this sounds a bit like event notification, so it might be a good idea to use the signal here. So let's go to the point counter, and now we are creating a custom signal. It's very easy to do. We can just say signal, and then we give the signal a name, point counted. And then instead of printing something when we count a point, we are emitting the signal. And we can emit a signal by just taking its name, point counted, and then calling emit. And this will emit this signal. So now all that is left is that we listen for this signal in our main script. And we already know how to subscribe to a signal through code. We can just say point counter, point counted, connect. And then we need to give it a function that this should call. So let's quickly make a function. Maybe let's call this onFishDied. And we give it the function up here. And now we can implement this. So we need to have a point counter. Right now we don't have one. So let's create a variable for that. Points. And whenever a fish dies, we increase the points by 1. And we update our score label. Okay, so now we can try it out. Our fish just impacted with the tower. We get 1 point here. Now this fish died and we get a second point here. So it looks like our autoload solution works nicely to count killed fish. So using an autoload seems to be a nice solution for the problem that we had, but an autoload is not without its drawbacks. When we look at how stuff works right now, whenever a fish dies, it needs to talk to our autoload, and then the autoload will talk to our main script to tell it that a fish has just died. And for our main script to be able to get notified by the autoload, it first needs to subscribe to the signal that is provided by the autoload. Now we have just introduced a hard dependency between two components, our main component and the fish component, to the autoload. So the fish can no longer work without the autoload, and the main can also no longer work without the autoload. And depending on the game that you're building, this may be totally fine. I mean, there's no need to make things more complicated than they need to be. But the more functionality you add, and the more autoloads you add, the more we get back into spaghetti land where every component just wildly talks to every other component. I think for a little game like this, it is totally fine. But say we wanted to make this whole thing work without an autoload. How could we do that? In order for this to work, we would need to have one component that knows every fish, because then it could get notified by the fish if they die. So, do you see a component in here that knows every fish? And maybe you pause the video and think a few seconds about this. I'm moving my cursor over here, and there we are. This is the component that knows all fish. That's the spawner. Whenever it spawns a new fish, it has the fish instance in its hands. Let's maybe have a look at the code here. So here we can see a new fish is instantiated and then it's added as a child to the spawner. And here it actually knows the fish. So if we now give our fish a signal that is always fired when the fish dies. So let's remove this point counter stuff here and remove this point counter stuff here. And we're creating a new signal. Signal died. And then instead of calling the point counter, we emit this signal. Died emit. And we do it here as well. So now in our spawner, we can subscribe to this signal. We can say new fish died, connect, and we make ourselves a new function, func on fish died, and we call it here. And now we add a new signal to the spawner, which we call fish died. Fish died. And whenever a fish dies, we just emit this signal. And now we can listen to this signal in our main script. We can remove this. And since the spawner is a component in the same scene, we can actually connect this through the editor. So we can go to our spawner, take the fish died signal and connect it to the main script on fish died. And now we don't need the autoload anymore. So we can remove it from our project settings. And maybe let's do a quick recap on how this works. So when the spawner spawns a new fish, it connects to the died signal of the fish. And when the fish dies, it tells the spawner that it has just died. And then the spawner tells our main game component that a fish has just died, and the main game component can update the label. But this time we are using signals to transmit this information, and we're not using a centralized autoload. And because of this, our components stay independent of each other. They don't need to know about each other anymore. So let's move it over here and give it a quick spin. And that didn't work at all. Why didn't it work? Well, interestingly enough, it works for these fish. See, we get an increased label here. So why doesn't it work for this fish, but it works for the other fish? Well, I think you know the answer already. The answer is that this fish is not spawned by this spawner. It's just placed by us, so it doesn't get its signal connected, and that's why it's not working for this fish. But it looks like we found a solution how to solve this without an autoload, and now our components are still independent of each other. And that's exactly what we want. We don't want the components to know more about each other than they absolutely need to. So now that we have the point counting done, the next step would be to end our game when more than a certain amount of fish have escaped. When the game ends, what should happen is that everything disappears except the two counters, and we add a little game over label here in the middle of our screen. So let's first add that label. We give it a scene unique name, rename it to game over label. Now we move it into the center and type game over and change the font size to 64. That should do it. And now we can go in our main component and add some code that shows the label. And we would do this in this on fish detector body entered function because here we count the units down. So first we need to have this label, so we can again control drag this into our script and move it up. And then we can check if maximum units true is less or equal than 0, then we show the game over label. And by default, we will make this invisible. And to test it, we will use our trusted test fish. I'll move it here. And since we need 2 fish to escape, we will make a second test fish. So our test fish now is company. And we can try it out. So 1 moves out, 2 moves out, and the game is over. So that is good, but we still need all of this to disappear. And for all of this to disappear, our main component somehow needs to know about all of these things. It needs to know about the tower, it needs to know about the projectiles, it needs to know about the fish. So how can our main game component know about all of these without knowing about all of these? And we can use a feature again that we already used, which are the groups. Because right now our tower is in the friend group, our fish is in the enemy group, and our projectile is currently in no group. But what if we would put all of them in a group that is maybe named destroyed on game over? Again, a group is just a little sticker that you can put on an object, and you can put as many as you want on them. So this is a really nice way of marking components so other components can quickly find them, and we will see how you can find these in a minute. So we have done the tower. Now we are going to do the fish. Destroyed on game over. And then the other fish. And finally the projectile. And now we can go back to our main script. And we can find all components that are in this destroyed on game over group. And we do this by asking the tree. So get tree. Could you please give me all nodes that are in group destroyed on game over? And we put these in a variable to destroy. And then we can just walk over them and we queue-free them. So let's run this. 1 fish out, 2 fish out, game is over. Except we have forgotten something. Our spawner is still alive. But that's an easy fix. We can also put this into the destroyed on game over group, and now it should work. So 1 fish out, 2 fish out, game's over, everything is destroyed. Now that worked just fine, but what if we wanted to keep the projectiles alive so they could just fly out while we kill everything else? Well, we could approach this as we did dealing damage to other units. We could make a contract. When you want to do something special at the end of the game, you need to have some method on game over. So let's implement this for the fish. We make a method on game over, and the fish will just destroy itself. And we're going to copy that because we're going to need this for the tower as well. On game over, we paste this in here. We also do this for our spawner, but we will do no such thing for the projectile. Now we have added this function, but we still need a way of calling this function. And usually if you want to call a function, you need to have the object on which you want to call this function in your hands. And this main game component does not. So how could it call this on game over function? Well, there's something built in Godot that allows every node to call a function on all of its child nodes. This is called propagate call. So we do propagate call, and then we need to give it the name of the function that we want to call on game over. And what this will do is it will go through all of the child nodes in the tree and will check, do you have a on game over function? And if the child node has such a function in the script, then this function will be called. And if it has not such a function, then nothing will happen. So it works really similar to how our damage dealing with the take damage function works. We don't need this destroyed on game over thing anymore, so we can quickly remove this. And now we can try it out. One fish through, two fish through. Fantastic, but our projectiles are still gone. To debug this, it would be nice to have a look at the tree before we do this propagate call. So we set a little breakpoint here, and then we run the game again. One fish through, two fish through, breakpoint. So now we can have a look at the remote tree. So we see what's going on here. Well, we have one projectile here. This also seems to be a projectile, and this also seems to be a projectile. And we see that all of these projectiles are children of the tower. Because if we go to the tower code, we can see that it simply adds the new projectile as its own child. And now when the tower is being destroyed in on game over, then it will just destroy its child projectiles with it. Because in Godot, when you destroy a node, it will automatically destroy all child nodes with it. So that's one more thing that we need to fix. So we need to tell our tower to which node it should append its children, and it should ideally not be the tower itself. Say we want to be really configurable and we want to make this a configuration setting. Well, we can do this with another export or parent for projectiles. And this is a node path. And now if we look in the inspector of the tower, we get a new field here where we can pick another node. And if we think about this, this is actually pretty useful because now the tower can interact with another node and it doesn't even know where this node is. Because the node path is not hard-coded, but it is now a configuration setting. So this is still a node path, and we need to get the actual node with the getNode function. So we say parent is getNode, parent for projectiles. Then we add the new projectile to the parent. So let's try out if this fixes our problem. Well, it fixes it sort of. The projectiles are still there, but they spawn at the wrong position. The reason for this is that when you add a new node, it will set its position relative to the parent to which you add it. And before we added it to the tower, so they spawn at the tower's position, but now we add it to the main node because that's the node that we have selected. So they spawn relative to the main node's position. But we can quickly fix this by just setting the global position of the new projectile to our own global position, and that should do the trick. Yeah, that works a lot nicer. So now when the game is over, the projectiles keep moving, but everything else is destroyed. So being able to configure the path of another node can actually be pretty helpful when you want to have components talk to each other that know nothing about each other. But as everything, it has its trade-offs. If we were to place this tower dynamically, maybe through a buy menu where the player could buy new towers, then we would somehow need to set up this path when placing the tower. And this is additional complexity. So in this special case, it is safe to assume that the projectile and the tower could have the same parent. And this would allow us to simplify this by removing this export. And then instead of doing a get node with this export, we just call get parent add child. And you probably have realized that whatever design choice you take, there's always a trade-off. So there's never that choice that is always correct, that is always the right thing to do. It always depends on the situation and also on how your game works. To make this into a fully fledged tower defense game, we would need to add quite a few more things, maybe a menu to buy stuff, more towers, more projectiles, different fish, graphical effects, sound, you name it, a lot of stuff. But this is not a tutorial on how to build a tower defense game, and I think I have shown everything that I wanted to show. So let's wrap it up here and have a look at what we learned. In this video, we learned about structuring a game into small components. We learned that a component has some small but useful functionality, works independently of other components, and can be reconfigured for easy prototyping and reuse. We also learned that it is useful when components know as little as possible about their surroundings and the inner workings of other components. This helps keeping them independent of each other and also allows to combine them more easily in different situations. We learned that there are ways in which we can access other components in order to communicate with them when hard-coded node paths are not enough, such as using the physics engine, groups, autoloads, or configurable node paths. And we learned that there are quite a few ways in which components can communicate without having to know a lot about each other, such as signals, contracts, signal relays, or propagated calls. Building a game is a complex matter, and knowing what options the engine provides you is a good first step in designing a game that you can easily extend and test. I have shown you a way that mimics the way Godot's built-in components are working. Therefore, it works quite well together with the engine. But it is by far not the only way or the correct way of doing things. Every game has its own requirements, and there are many solutions to a single problem. It is also important to not over-engineer things in the search for some perfect solution. Sometimes a quick and simple solution is preferable to one that may be nicer on paper, but just adds unnecessary complexity. Finding a solution that is both simple and nice will usually take a few iterations. So don't be discouraged if you are occasionally back in spaghetti land. If you have any questions or some experience of your own that you want to share, please post them in the comments. If you liked this video, please give it a thumbs up and consider subscribing to the channel to get notified when new videos are posted. Thank you very much, and happy Godotneering!